All right, so this is part 4 of our lesson reviewing polynomials. We're going to pick up here with number 22 and 23. In this video, we're going to focus on writing a polynomial to match the given zeros. Okay, so if they give us these zeros, each one of these zeros can be translated into a factor. So a 0 of 3 corresponds to a factor of x minus 3. Because remember, if you have a factor, x minus 3, the way you find the zeros is you set it equal to 0 and you solve. So you wind up doing plus 3 on both sides, so you get x equals 3. Okay, so all we're doing is we're working backwards. So anyway, you see this negative 1? That corresponds to a factor of x plus 1. This 2 means would come from a factor of x minus 2. And this negative 2 would come from a factor of x plus 2. Okay, so all we need to do is multiply this all out. So I would recommend doing 2 at a time. So for example, if I do these two, double distribute. Okay, if you double distribute x times x, okay, so I've got x squared, I've got 2x, and then if I double distribute right here, that's going to be minus 2x minus 4. So these cancel out, so that's going to give me x squared minus 4, which makes sense because that's the difference of two squares would be x plus 2x minus 2. So, you know what, I'm going to change colors for the left side. Now looking at these two over here, if I double distribute, so I've got x times x, so that's x squared. X times 1 is x. And if I do the negative 3, that's negative 3x minus 3. Putting these like terms together, I will have x squared minus 2x minus 3. Okay, so now I need to multiply these two together. All right, I feel like I need more space. Maybe if I just bring it down a little bit. So x squared minus 2x minus 3. So I need to double distribute this.
And actually, would anybody care if I rearrange the order of these? I like my trinomial to come second. So I'm going to take this and I'm going to write it over here. Obviously, it's the same thing. So I'm just going to put my x squared minus 2x minus 3 over here on the right, if you don't mind. Okay, so now I'm going to do my double distributive property. So if I do my x squared times x squared, of course, that's going to be x to the 4th power. And then x squared times negative 2x is going to give me negative 2x to the 3rd power. And then x squared times negative 3 will give me negative 3x squared. All right, now I'm going to double distribute the negative 4 times everything. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 2x is positive 8x. And negative 4 times negative 3 is positive 12. So finally, when I combine my like terms, which are really just my only like terms are these, so then I will have for my final answer x to the 4th power minus 2x to the 3rd power minus 7x squared plus 8x plus 12. And there's my final answer.
Okay, so that is the polynomial that we're looking for. Okay, let's do the same thing with number 23. Now be careful, this one has imaginary in it. Imaginary zeros always occur in pairs called conjugate pairs. So if you have 4i is a 0, then you will also have negative 4i. They go together. Okay, so let's turn these into factors. So a negative 4 would come from a factor of x plus 4i. A positive 4i would come from a factor of x minus 4i. And then the negative 2 would come from a factor of x plus 2. Now, if I were you, I would double distribute the two imaginary factors first. Okay, so let's double distribute this. So if I multiply by x, that's going to give me x times x is x squared, and x times negative 4i is negative 4ix. And then if I do this one, 4i times x is positive 4ix. 4i times 4i is negative 16i squared. Okay, now don't forget I still have this blue part out here. Okay, I still have the x plus 2. Now, there's a couple of things. These middle terms cancel out. Negative 4ix, positive 4ix. But also, what about I squared? Did you remember that that's equal to negative 1? So if you understand that this is really negative 1, then what I have here is negative 16 times negative 1. So that is a positive 16. Alright, so that means what I have here is x squared plus 16. Okay, and that's being multiplied by the x plus 2. So let's go ahead and double distribute once again. Alright, so if I multiply x squared times everything, x squared times x to the third power is x squared times x is x to the third power. X squared times 2 is 2x squared. Alright, and then we will do 16 times everything. 16 times x is 16x. 16 times 2 is 32. And look, everything is already in the right order. So this is really the final answer. Alright, so that is the answer for number 23. Alright, number 24. We are supposed to use the following graph to answer the questions. So let's see what questions. Give a possible factorization of this function. Well, let's look at the zeros. We have a 0 at negative 3. Okay, so that would correspond to a factor of x plus 3. We have a 0 at positive 2. So that would correspond to a factor of x minus 2. And we have a 0 at positive 4. So that would be like x minus 4. So this is a possible factorization right there. And behavior. Now, so they have negative infinity on the bottom. So this is left. And this one is as we go to the right. Okay, so as x approaches positive infinity, in other words, as we go to the right, what happens to the y values? Okay, so here on the end, as we're going to the right, we wind up going down, down, downhill forever. So that's why the graph approaches negative infinity on the right. Now on the left, I know it's the left because it says the x values are approaching negative infinity. So the question is, what happens to the y values? Okay, so look at the graph. As I go to the left, I'm going uphill and downhill and uphill. But all that matters here is what happens on the end. On the end, I go up, 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 up. So that is positive infinity. Okay, so that's your end behavior. Absolute minimum, absolute maximum. This graph has neither an absolute minimum nor an absolute maximum. We are supposed to assume that this graph continues forever, like they do, and on both ends. So even though it might look like this is the low point, it really isn't, because this graph continues on like this forever. So there is no lowest point and there is no highest point. So absolute maximum, none. Absolute minimum, none. But what we do have is a relative maximum and a relative minimum. The relative maximum will be at the top of a little hill. So this is not the highest point on the graph because of this, but it is the highest point in this neighborhood. So we have a relative maximum. And let's just put the ordered pair. This is 3, comma, well, it's 3, comma 3. Okay, and then we have a relative minimum here at the bottom. And that's -1, comma, -15. Okay, intervals of increasing and decreasing. So a minute ago I was talking about how we consider ourselves going up and down like a roller coaster or something. Let's talk about that again. When you do these increasing and decreasing intervals, you have to read the graph from left to right. So as I go from left to right, I start off in a decreasing mode. Okay, so I'm starting here from infinity. Hold on, I've got glitch-tastic. Now, I am going downhill at first. Downhill, 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 until I get to the bottom. And then it changes, and now I'm going uphill for a while. Until I get to the top. And then I'm going downhill again after that. All right, and then I'd be going downhill forever. So the pink parts are where I was going downhill, because downhill, uphill, downhill. So the pink parts are the decreasing, and the green part is increasing interval. Okay, so they wanted increasing interval first. So we've just got this one green. Now understand that we are dealing with x values only. So let's see, what's the x value right here? It's -1. And what's the x value right here? It's 3. So we're talking about from -1 to 3 is where it is increasing. So we'll put -1 to 3 like that. We will use round parentheses because right at -1 it's neither increasing nor decreasing. So we can't include it in the set of increasing values. Now what about intervals of decreasing? Well, there are 2 of those. Over here on the end, this is negative infinity. All right, you might have been thinking positive infinity because it's going up. but we're only talking about x values. And x values wise, this is going to the left forever. So that's negative infinity to negative 1 is the first interval. So negative infinity to negative 1. And there's two of them, so I'm going to need this union business. All right, so this one goes from 3 to positive infinity. Again, you might think it was negative infinity because it's going down. But when you say down, you're talking about y values. I don't care about y values. I'm doing x values. And it's positive infinity because this is heading over to the right. All right, so 3 to infinity. Okay, so we are supposed to solve and graph these things, inequalities on a number line, and we're going to do interval notation. So what you want to do is get everything on one side. So let's subtract 2x from both sides. All right, subtract 2x from both sides. And we're also going to need to subtract 5 from both sides. So that will give us 2x squared. All right, now positive x and negative 2x is positive 1x. I'm sorry, negative 1x. And then we have the minus 5. And that has got to be less than 0. So let's try to factor it, but we might have to do the quadratic formula. Two x squared can only be 2x and x. All right? The best I can do with 5 is to go 5 and 1. But inner, I would have 5x. Outer, I would have 2x. That's not going to make it negative 1. Okay, so this is unfactorable. So let's go back and do the quadratic formula. Okay, the quadratic formula starts with the b squared minus 4ac part. So let's get that done. All right, b squared, so that's negative 1 squared minus 4ac. All right, so that turns out to be 39. Okay, so if we go ahead and do the rest of the quadratic formula, it says that x will equal the opposite of b. B is negative 1, so opposite of b plus or minus square root of 39, because we already did the b squared minus 4ac part, all over 2a. 2 times 2 is 4. Okay, so let's translate this into some decimals. All right, so 1 plus radical 39 over 4. Okay, don't write it backwards the way they did. All right, so as a decimal, let's round to 2 decimal places. That's 1.81. All right, now let's do 1 minus radical 39 over 4. Okay, ignore that and just toggle it again. So that's negative 1.31. Negative 1.31. Okay, so these are the zeros of the function. Okay, These are the values where the function equals 0. Maybe I shouldn't have tried to circle them. All right, so now let's see if we can finish the problem from here. All right, let's get a number line going. All right, can't be a very, very big number line, but we'll do the best we can. So here comes a number line. We have negative 1.31. I'll put that like here. And positive 1.81. All right, so here's where we make sort of a table of values, remember? And I'm running very low on space, but we are going to check x values in each one of these zones. So to the left of negative 1.31 is negative 2. That's a good one to check. Between these two is 0, so let's check that out. To the right of 1.81 is 2, so let's check that out. All right, now as long as we're allowed to use our TI-30 XS multiview, I say we use it. Okay, let's put in this version of the formula right here. So 2x squared minus x minus 5. Okay, so I'm interested in knowing what happens at x equals negative 2, so I might as well start there. Okay, so at negative 2, I have a value of 5. Okay, now we want the values that are less than 0. Okay, so is 5 less than 0? No, 5 is not less than 0. So that's sort of a fail. Now let's check out what happens at x equals 0. Well, at 0 we got negative 5. Is negative 5 less than 0? Yes. All negative numbers are less than 0. What happens at x equals 2? At x equals 2, the y value is 1. Is 1 less than 0? No, of course not. So the solutions are in this middle zone, all right, because of the yes. There are no solutions in the other zone. So to reflect that, we will show our endpoints right here, and we will connect these dots to show that all the solutions are in between here. Now, let's see, should we leave it open circles or shade them in, the endpoints? Well, it just said less than 0. The endpoints are where it equals 0, not less than 0. So we're going to leave it like that. So that's the number line graph. All we need now is the interval notation. And it would look like this. The interval notation would be negative 1.31, comma 1.81. It looks like an ordered pair, but in this context it means all of the values between negative 1.31 and 1.81, but not including. If these had been closed circles, I would have put square brackets on these numbers. Okay, so I'll put a box around that. That's the interval notation. Okay, so number 26, last problem of the lesson. I would love to factor this if possible, but you know, I can already tell that grouping is not going to work, so that's not looking too good for me. Let me see how many zeros we can find on the TI-30. Okay, so we're just going to type this thing in. All right, so I've got x to the third power plus x squared. So x to the third power plus x squared minus 26x plus 24. Oh, I said 24, but I wrote 25. That's a problem. Okay, so now we've got it in there. So let's look and see if we can find any zeros. All right, so a zero is, if we see 0 on the y side, that means the x value is a 0. So right away I see that 1 is a 0 of the function. So I'm going to scroll around a little bit more. Let me scroll up to 10 at least. There's another one. All right, so I've got 1 and 4 so far. Anything else? That is not 1, by the way. Whoa, there's another one. So we have 1, 4, and -6. That's a bunch. Okay, so I've got zeros at 1, 4, and -6. Oh, and you know what? That's all of them. Because you see that it is degree 3. So at most, there will be 3 zeros. And we found them all. So we can go ahead and start doing our number line then. We're very special. Okay, so our number line... Our number line will show our zeros, so -6, 1, and 4. And we will use these values to make our little chart. Okay, let's see, I need space, right? Because I need 1, 2, 3, 4 zones. Okay, so I need a test value in each zone. So over here to the far left, let's try x equals -7. Between -6 and 1, let's try x equals 0, actually. Yeah, -6 and 1, 0 is in there. Between 1 and 4, let's try x equals 2. And then beyond 4, let's try x equals 5. Now you can pick whatever values you want as long as you choose one value in each one of these zones to test. All right, now we want the function to be greater than or equal to 0. These values are where the function equals 0, so we can go ahead and show them as closed circles. All right, they will be part of the solution set. Okay, so now we need to find out what happens everywhere else. Now remember, we want things to be greater than or equal to 0. In fact, maybe I'll just write that down everywhere. Greater than or equal to 0. Greater than or equal to 0. Whoops. That's what we want. So let's see what happens at -7. At -7, the y value is -88. All right, is -88 greater than or equal to 0? No, so there won't be any solutions in that zone. What about at x equals 0? The value of the function is 24. Is 24 greater than or equal to 0? Yes. What about at 2? -16. Is -16 greater than or equal to 0? No, that's a negative number. What about at 5? At 5, we're at 44. Is 44 greater than or equal to 0? Yes. All right, so we have no, yes, no, yes. So the solutions are where we got a yes, a true statement. All right, so that means we'll have solutions between here and here. So that was my no, my yes, my no, and my yes. Okay, so now all we need is that interval notation. Okay, and we'll have to do this in pieces. So for this part right here, we will do -6 to 1. Notice the square brackets because they're closed circles. And then we'll do union. And then here we have 4 to infinity. Okay, that is how you graph an inequality on a number line and interval notation. And that is the end of this review, part 4. I hope it was helpful. I will see you on the next video.